antenna system. Now, let us look at design of an omnidirectional antenna system in the worst case. It is given as in the worst case. Now, let us look at this one. What is meant by the worst case? Now here it is. The worst case is at the location where the mobile unit would receive the weakest signal from its own cell site, but strong interferences from all interfering cell site. For example, worst case means if we take one area in that particular cell site, only one particular area where we are standing. For example, it may be our college building. If there is a weak signal and suddenly there are some interference noises or cross connections, then that particular zone is referred as a worst case. Now, here, what is the main thing we have to prove? Now, we are trying to prove that this so-called k equals to 7, which we discussed so many times, cell pattern does not provide a sufficient frequency reuse distance. Now, this 7 cell, what we use frequently, is not a mandatory one to say that it is going to give us the best frequency reuse. Let us look at the worst case. Let us see this, how these cells are given. Now, in this 7 cells, if we say that this cell site is on which the particular mobile unit is available, you can see with this circle here. Now, if we say this circle is considered as the location where the signal is very weak and the interference is at the peak. Now, when we make the distances from this particular area, we go along with these distance areas. One D, next one approximately D minus R distance. One is approximately D plus R. D means distance plus its radius of the particular cell site on which we are standing. These two are D directly. They are directly connected. Means they are very border. These two cells are very border. We can simply say they are at a normal distance. The remaining are either it be D plus R, either it be D minus R. Now we go with these conditions: one D plus R, one D minus R conditions, distance and radius. When we take these things into the formula, what we have, we know this carrier is how this carrier is proportional to radius and how this interference is proportional to distance from our previous formula. This C is directly proportional to radius, I is directly proportional to D, but to the power of minus 4. When we know that whenever we calculate this so-called value, we calculate with respect to C by I, that is carrier to interference ratio. That equals to, let us take this formula, substitute these values. When you substitute these values here, you can able to see this R power minus 4. This is with respect to the values what we have for the worst case. Two values are there. That's why I have written 2 times here. 2 values here. 2 times means 2 values of D are there, 2 values of D minus R are there, 2 values of D plus R are there. Now, we have the relationship between D, R, and Q. If we use that particular relationship, Q equals to D, R, the relationship between D, R, and Q, there is co-channel interference reduction factor. When we substitute this one, we are going to get this formation, that is 1 by 2 into Q minus 1 whole power minus 4 plus 2 into Q power minus 4 plus 2 into Q plus 1 whole power minus 4. We are going to get this formation. We are using this formula and we are using this worst case scenario in which the particular location, that is worst case location, is at the distances of D, D plus R, D minus R. These locations are utilized here. When you use this in the formula here, when we say where, if you say Q equals to 4.6, this is the famous value we remember in our this so-called interference frequency reuse distance factors. When you use this particular value of 4.6, the C by I is automatically given by 17 decibels. But actually, to have a good connection, from the first chapter, we have said that the basic value must be lower than, it must be a value of 18 decibels, but the 17 decibels here it is. which is lower than 18 decibels. Then we are moving towards shortest distance, that is D minus R directly. Means we are considering only the shortest distance D minus R. Then what happens? This particular all the values will be neglected. We take only D minus R as the 6 cells available for the particular cell site. If you substitute that value here, we can observe the answer is going to be around 14.47 decibels. Now, once again, it is somewhat less value. Now, therefore, in an omnidirectional cell system, what we are going to say that not only k equals to 7, there must be k equals to 9 or k equals to 12 would be a correct type. But we know that these are all mathematical equations. When it comes to the practical grounds, they are not at all any correct. If you go along, if you say that for an omnidirectional means in the last class we have seen how these omnidirectional antennas are replaced by directional antennas in the cell sectorization process. Now we are looking up after the omnidirectional only. It is saying that rather than going for k equals to 7, better to go for k equals to 9, k equals to 12 with respect to the mathematical formula, what we achieve it. Then these values of QR, let us look at these values, how they will be. They will be like this, 5.2 for k equals to 9, 6 for k equals to 12. Then let us use this formula for k equals to 9 and k equals to 12. This ratio C by I equals to 19.25 decibels and C by I that equals to 22.54 decibels. As per our theoretical aspects, that is, the value must be equal to or greater than 18 decibels to achieve a good voice communication. We can say this 9 or 12 might be better as per the mathematical approach. But once again, I'm repeating, this is only a mathematical approach. When it comes to practical approach, it is in between 7 and 9 sometimes, which cannot be calculated in the mathematical equation. Now, as per this design, we can say that we can choose for either k equals to 9 or k equals to 12 pattern because it gives us the decibel range which is required for a good voice greater than 18 decibels. That's why we choose for k equals to 9 or k equals to 12. This is about the design of omnidirectional antenna for the worst case.